Got my face blasted with some walnuts. Just a little bit though, it didn't hurt. Low velocity nut slingage. This thing is just loaded with it. It's a circular cheetah. Hello everybody, good day to you guys and welcome back. I want to do a bit of apples to oranges comparison. This is going to be a short video. We are going to do some work in this, but I want to talk about the difference between a service that I debuted the other day with this, what I've dubbed the R2D2 machine, in comparison and versus a chemical intake and valve cleaning system. You guys have seen on the channel many times where I install some cleaners and I run these through engines, as well as installing additives to fuel tanks to clean out fuel systems. Well, the other day I had a Toyota Prius in here with the intake valve or intake manifold removed, and while the intake was off, I used this machine, which is a Walnut shell media blaster, and I blasted the carbon out of the intake runners on this 1.8 liter 4-cylinder on this Prius motor that I had. And a commenter had chimed in and said, well, Ray, you were in the past using these chemical cleaners for intakes and valves. Why all of a sudden did you switch to a media blaster? Does that mean that the chemicals are irrelevant and you should not use them? Did I waste money on them? Or should I just focus on like a scheduled maintenance regimen where I have the intake manifold removed and somebody goes in and manually blasts these out? And in a short, the best way to sum that up in a short answer is a no. This right here, this procedure through walnut blasting is actually a highly invasive type of procedure, because you can't just run this stuff through an engine. You've got to make sure you can extract all of these little granules from the engine and not let the thing start and run with this stuff inside of it. Yes, it is biodegradable and these things are not remarkably hard. So if you did end up getting like leftover granules in the engine, the risk of damage is remarkably minimal, but that's not the reason that I say apples to oranges. Primary reason being is actually going to be cost and maintenance versus repair. This is more of a repair type of situation, and again, you can't just do this very lightly, because you have to take the engine apart in order to access those areas of the vehicle. And I will show you over here on this 2.3 liter Mazda engine. We can see there is no intake manifold. If we were to take a peek down inside of these intake ports, we can see down there, there is an immense amount of carbon built up on top of those valves. You guys see all that right there? This thing is loaded full of buildup. Now, again, in order to media blast that out, what we have to do is take off the entire intake system. And I've got the old engine that's being replaced over here on the ground, and I'll show you kind of what that looks like. Here's our intake manifold. Our valve runners and everything are back there. In order to get this off, we have to disconnect the charge air cooler, because this is turbocharged, the intake, a bunch of plumbing, probably have to remove the dipstick tube. Needless to say, it's rather invasive, time consuming and labor intensive to gain access to those valve ports. So the application of the media / walnut shell blasting is really only applicable in an instance where you have an engine out of the vehicle or it's already taken apart. So again, when I call this apples to oranges, we're not really in the same ballpark. It's not the same fruit. It's not the same operation. When we utilize the chemical cleaners, the main goal here is to prevent that carbon buildup. So when you've got an engine with 30,000 miles on it, or 20,000 or 40,000, it's a prime candidate for a cleaner such as this. Once they reach a state of buildup like that, it would require multiple treatments in order to break this down and get that stuff fully cleaned. And so it would have to happen over time. So the best way to look at this is to use your chemical cleaners, you know, your BG stuff or your Amsoil stuff or your Seafoam. The maintenance cleanings are a way to prevent this kind of buildup. But once you get to this point, these are not as effective as actually physically going in there and cleaning that stuff out. Now before I owned the Walnut blaster, on a situation like this, I would spray just a bunch of brake clean in there and then go in there with a brush and wash it all out, and it's a huge giant mess. The addition of that media blaster machine over there makes this a nice, quick and clean operation where I'd have to go through all that extra rigmarole just to decarbon some intake runners on an engine. So I'm hoping that clears it up, if that makes any sense. If there's any further questions on the topic, please register them down in this comment section below at the bottom of this video. So basically, for everybody who's using these chemical cleaners, you're doing the right thing. Keep doing what you're doing. It's going to prevent those kinds of a problem, those types of problems, unless you have a vehicle that you cannot run a chemical cleaner through. For example, you don't want to pump this stuff through a supercharger or a turbocharged engine, because that actually could potentially result in damage to those components, especially turbochargers, because those things are running off of the exhaust heat and the exhaust pressure. Well, when you're dumping cleaners in there, you're chooching a bunch of smoke through. You may dislodge some carbon, and that carbon could impact the turbine blade on the compressor. And if that compressor is spooled up, or that turbine is spooled up at that time, then it could actually impact that piece of carbon at incredible speed and chip the blade, or damage the blade, or throw it out of balance. So it's best to avoid running these chemical cleaners through turbocharged engines. And I know people do it. I prefer not to, because there is a liability involved, and it's not necessarily beneficial. One other thing on that note, there are some engines that are just so prone to carbon buildup. A lot of the Volkswagens are like this. Some of the Audis, I believe BMWs are like this. They have especially the direct injection, which is it's a type of the fuel injection. I'll explain it right now. DI, this is a direct injection engine. On a normal port injection engine, you would have a fuel injector somewhere in the intake manifold, and a portion of that fuel would serve as a solvent and as a cleaner. You can see that fuel injector right there? That's going to spray our fuel in. Yeah, right there. See where it's clean? Where the fuel spray is? And that fuel is keeping the carbon buildup from taking place on this engine. On a DI engine, such as this one, the fuel injector actually goes straight into the combustion chamber, bypassing the intake and the valves altogether. So there's no opportunity for that fuel to provide any type of cleaning. And again, some of the European vehicles are remarkably prone to carbon buildup due to just their design nature, because they are direct injection. This is actually a similar system to a common rail diesel, where you've got one fuel rail that runs at a higher pressure, and then the injectors are they're feeding their fuel off of that single rail. There are pros and there are cons to both systems. One of the major cons and fallbacks, again, with direct injection is the lack of the ability to clean on its way in. So these engines would benefit greatly from a regular cleaning product at 30,000 mile intervals or 40,000 intervals to prevent this type of buildup. And yes, these cleaners will break this down, but it often requires 2, perhaps even 3 applications to get that fully clean. So having said all that, I did promise you guys some actual work in this video, and that's what we are going to do today on this particular engine right here. Since it's out of the vehicle, it's convenient to run the service, the machine is there, and we clearly see that these DI fuel injectors, or this DI engine, as a massive carbon buildup problem, and we're gonna clean that out straight away and get this thing nice and shiny in preparation for the new clutch that has yet to arrive, and then in preparation for reassembly, and we're gonna put this thing back inside of the vehicle. So let's go ahead and get that done, and that will probably conclude the question and answer segment of this video here. So what I'm gonna need, we're gonna need looks like a 21mm wrench, because I am gonna have to turn this engine over a little bit to at least clean out one of these cylinders. What we noticed, especially on number 2, is that those intake valves were slightly open. That's the other catch about this procedure, is we have to make sure that those valves are in the closed position. That way we do not contaminate the combustion chamber with the Walnut blasting media, because we don't want to have that stuff floating around in there, jamming up the piston rings, scratching the cylinder walls. We only want to clean out the intake ports and the valves and nothing more. I mean, unless we pull the cylinder head off, then I could probably clean out the chamber, but we're not going to do that, because I'm just not I'm just not going to do that. That's not what's in the cards here. Now, you also may ask, why am I doing this again when we just made a video about the R2D2 blasting machine on that Prius engine? And once again, that Prius engine was a port injection engine, so the valves were not terribly bad on that one. There was carbon buildup, but it wasn't as bad as this one is, so we're going to get a much better before and after result on this DI engine as opposed to that Prius engine. If you would like to see the video on that Prius, again, there will be a link for it down inside of this video's description below. So let me give you one quick explanation on the nature of this machine. It clearly looks like a shop vac, and it performs a similar function as a shop vac. There is a vacuum motor in there in the top here. We've got a filter in between, and then there is the blasting media in the lower compartment below, okay? Now this hose here, this is the suction feed hose for the wand. So as I squeeze this trigger, it's gonna send pressurized air, which will connect to the machine through that fitting right there. It'll send pressurized air through this hose, up through the wand, and across the top of this larger hose. That pressurized air at its fast moving velocity is going to create a negative or lower pressure in the suction hose, and that's going to draw up the walnut media, which pulls through like a screen at the bottom of the machine here. So as I blow air through this, it's going to pick up the walnut and then blast it out of the business end of the machine right there. Simultaneously, on the vacuum side of this machine, I will place an adapter on the business end there, and we're going to hold that over the port as I insert the wand in through the access hole in the adapter, which is losing my down here on the floor. Yep, the access hole through the adapter. So we'll plug this guy up, run the wand into it, pressurize the walnut, blast it all through the cylinder or through the intake, and then as it's blasting, the vacuum side of the machine is sucking in that media and then recycling it back into the machine so it can just be used over and over and over again. That way we can blast without a loss of our blasting media. So let's go ahead and get started. I'm going to take some air from the airline here. We're going to blow off all this dirt and stuff so we don't have debris flying around everywhere. And then we're going to go ahead and unplug these ports, and we're going to clean them out. And we're going to see one really good example of a before and an after of this walnut blasting procedure. So here, let's just de-dustify the thing. We can see everything that has a hole in it is already plugged up, so there's no risk of internal contamination. Let's just blow off all that dirt real fast. There we go. Hey, my air pressure's low. I believe the compressor is shut down. Uh-oh. Side quest. Fire up the compressor. There we go. Beginning all of the loud noises. So here, while that compressor comes up, let's see which one of these holes we're going to start with. Now, we saw on this one, those valves look like they were open slightly, so we're probably going to have to do that one last. These valves, those are open slightly, so we're not blasting those just yet. Let's plug them back up. A lot of you guys in the comment section said I should be using tape to cover this up with. I'm afraid I actually do not have any masking tape here, or if I do, I can't find it. But I will alter my strategy in the future to incorporate masking tape. This one, that one's very closed. We're good to go on that. These holes right here go nowhere, so there's no need to plug those up. Those are not cooling jackets, and there's no airflow. That caused some confusion in the previous video as well. Now, down in that hole, those valves are looking good. So we're gonna start with these two cylinders first. After they're clean, we'll plug them back up again. We're gonna rotate the crankshaft, which is gonna rotate the camshafts, which is gonna allow these two cylinders to close their intake valves, and then we can move the blasting over to cylinder 1 and 2. All right, air pressure's coming up. Let's power the pressure side of the machine. Vacuum side. Extension cord's not plugged in. Cut! Good to go. Hey, we traded one noise for another. Compressor shut down, vacuum turned on. All right, guys, we're going in. We're gonna do one at a time here, I think. vacuum's in place, we're going to take the wand in the hole, right? We're going to send it blasting right now. There is media flying into that hole down there. I'm just going to blast it and blast it and blast it. And I can blast all I want because the blasting media is recycled in the machine. Going a little deeper here. Okay, let's get the next one. Same thing, we'll start at the front of the valve and work our way down. You see the walnut media flowing through the tube right here. That one's looking good. Let's get the next one. Last one, that's kind of a tight squeeze there. Okay. Now we are left with one slight issue here, and I wish the machine had a provision to solve that issue. See how we've got the shut-off valve right here for the airflow? That prevents me from sending pressurized air through. Well, at this point I need to send pressurized air through, and I need to shut down the walnut media from entering the system, but I don't have a valve on this, so I'll have to switch this out to a regular air gun. Reason being is these valves will fill up full of walnut shell. See that in there on top of the valves? Now we're full of walnut shell because there's no air coming in without the walnut coming in with it to displace this current amount of shell, and the vacuum just simply can't suck it up. So we're going to reapply the vacuum, but I'm going to switch out this wand with a regular air wand just to disturb those granules in there, get them blowing around, that way the vacuum can suck them back up. So it's one extra step. A little bit of a design improvement on the machine could have prevented that extra step, but it is what it is. For an Amazon tool, I'll take it. So I'm switched out to the air blowing nozzle, vacuum back on, and we're just going to blow a bunch of air in there with no walnut. How are we looking? Good looking. Let's see. Yeah, we need to go a little bit harder on it. I still see some carbon in there, but that also may be a result of that walnut pooling up on the valve face. See how that is? It was blocking the valves from becoming fully cleaned, especially this cylinder here. Yep. So now what I need to do is start again, but we're going to start blasting from the bottom instead of starting up here at the top. So we've already cleaned the runners out. Now I want to clean the valves out. Machine powering on again. Go all the way down. Here we go. that got me. Got my face blasted with some walnuts. Just a little bit though, it didn't hurt. Low velocity nut slingage. Let's see here. Let's get this right. Much more shinier. This one needs a little bit more attention. There's still some carbon on that valve stem. We'll hit that one again. And this one needs another hit. And that one, yeah, I'm just gonna hit them all again one last time. That is what we call nice and shiny. That's gorgeous in there. I'd call that the most effective cleaning procedure I've ever encountered. Yeah, what do you guys think? How's that looking in there? I think we're good. We're super good. Okay, so next what I'm going to do, we're going to go ahead and close these off with some tape. Pull the plugs out of these two, use the wrench, turn the engine over until cylinders 1 and 2 are closed, and then we can clean those ones out. And by the way, this could be slightly confusing. Both of these are intake valves. So 2 intake, 2 intake, 2 and 2. The exhaust valves are on the other side of the head, and no, we do not clean out exhaust valves. Because we'd have to take off the exhaust manifold to do such things. And they don't carbon up the way that the intake valves do. It's a heat thing. Okay, so I'm gonna learn from my mistakes with those first cylinders, and I'm gonna start the blasting at the bottom on the valve face. That way that gets the most attention right from the get-go. And hopefully this walnut business will not be pooling up, so to speak, at the valve faces. So we're back on with the machine. Suctioning, probing deep like, we're gonna probe like this far, there we go. Send it. How are we looking? Good looking. Let's see what we get in here. Yep, definitely some improvement action. Super nice and shiny. Oh yeah. let's blast out the rest of those nuts. Finish cleaning that up, and I think this example is it's good to go here. Switching out wands yet again. Extra processes and whatnot. Can't see. Oh yeah, beautiful. How do we do on the back? That one needs some more attention on the back side of that valve. This one needs some more attention on the front side of the valve, and this one needs a little bit up front here as well. Okay, yeah, stuff takes some time, due diligence. It'll pay off though. Round 4 or 7 or whatever. See how we're looking now. I think we're all super clean in there. That one's great. This one is also remarkably clean. That one there, I see no more, except there's a little bit on the lower right hand corner on that one. I can barely see it. I gotta hit this one more time. But this one, that one right there is absolutely spotless. Fantastic. All right, one more hit on this runner here at the bottom corner back here, and we should be ready to rock and roll. Powering on. We get it right there, I think. Okay, one final blowout with the air. I broke my thing. I didn't really break it, it just came off. A little bit more air in here. We'll blow it out the rest of the way. Make sure these ones are good. Alrighty folks, I think that is going to conclude this walnut blasting procedure on these intake valves right here. What do you guys think about this procedure? Let me know if you have any additional questions, comments, or concerns about what we're doing here. I do not believe this stuff is hard enough to damage things like fuel injector nozzles. It's not going to tear up the valves. Even if there is a granule or two that sticks somewhere inside of the head where we can't find it, it will be consumed very efficiently by the combustion process should it make its way into the cylinder head. or into the combustion chamber. The risk of damage is remarkably minimal, and I think the results are well worth the effort. Again, what do you guys think about this procedure? Let me know in the comment section down below. Again, I really hope I've cleared up some of the questions and concerns about comparing apples to oranges. One is an invasive procedure, one is more of a maintenance procedure. Yes, this stuff can take down that amount of carbon, but it's often going to require more than one treatment. And I think it's more cost effective to use the chemical cleaners, use them early, use them regularly on a schedule, and it will prevent the need in most circumstances to have to go in here and do such things. And also keep in mind that this is not really common practice in the automotive world. There is a lot of risk here, and to turn over a machine like this to the uninitiated or somebody who's untrained, or someone who just works here, you may end up causing more damage than you do some good. Again, this can be messed up. It is a dangerous machine. You could blast like walnuts in your face and you'd have nuts in your eye. No business wants that kind of liability, or most businesses do not want that kind of liability. And so a machine like this and a procedure such as this usually only fits into a niche market, and you're not going to get a lot of availability for this procedure in like in the aftermarket, for example. Again, a lot of the BMW shops use such things, but seeing this in commonplace in like a retail store, or even in some like domestic dealerships, they're just not going to offer this type of service. So this is it's a specialty service. I really would not be too concerned about using the chemical cleaners. This is the industry standard, not this over here. This is just me doing what I do and taking this concept of cleaning intakes just a little bit further. So again, guys, as always, let me know what you think about this in the comment section down below. Do not forget to tap that like and subscribe button while you're down there. Thank you for watching this short video. I appreciate your feedback on every video that you guys comment on. That's going to pretty much close this one out. As always, thank you guys one more time for watching, and most importantly, don't forget to have yourselves a great day. See you guys later. Into Mazda, into valve cleaning, end of carbon, seriously, end of carbon, into transmission.